So I'm Dom Winski. I'm a climate scientist at the University of Maine. So that means it's my job to understand the Earth's climate, how it works, why it changes, and what that means for ecosystems and society. So there are many ways to do this. Climate scientists study a huge variety of things to help us understand how the Earth's climate has changed in the past and present. My favorite way of doing this is with ice cores. Ice cores record a wealth of information about the past climate. You can learn an incredible amount about what the environment, what the atmosphere, what the oceans were like in times thousands of years ago. So that's what I do. I go to places like Alaska or Greenland or Antarctica, and I collect these ice cores. Then I bring them home to our universities to analyze the chemistry and the physical properties of the ice in our laboratories. And then once we have that information, I spend a lot of time actually interpreting it, looking at the data that come from these ice core studies and trying to figure out what it actually means. And then lastly, and critically, I spend a lot of time communicating the results of this research to other scientists and to the public. So I love this job for a number of reasons. First of all, because I think it really matters. I think that the health of our ecosystems and society really depends on our knowledge of the climate system and how it is going to change in the future. And by extension, our decisions that reflect our knowledge of those systems. So I think this is really important work, and that's part of why I like my job. So another thing I really like about being a climate scientist is that it allows me to travel to really remote and spectacular places that very few people get to see and that I would have never gotten to visit otherwise. I've gotten to visit the South Pole, I've gotten to go to extremely high mountains that are very difficult to access, really spectacular places that I've seen through my work. And I feel very privileged to get to be a part of it. Another thing I find fascinating about this job is just the practice of taking numerical data, so the kind of data that you get from an ice core, really just a series of numbers, and then figuring out what those series of numbers mean in terms of actual concepts and processes. I think it's fantastic fuel for the imagination to be able to take records from an ice core and then imagine what the world was like and what processes helped to shape it. So I think that's really fascinating. In my off time, I really am motivated by just spending a lot of time in the outdoors. I spend as much time as I can get hiking, camping, paddling, basically doing whatever I can to be out in wild places and in the forest and along the coastline here in Maine and elsewhere. I have a wife and I have a 16-month-old son, and we all enjoy doing those things together. When I'm relaxing indoors, I like to watch an episode of Star Trek, play computer games on my laptop, and sit down with a big bowl of popcorn. So the data that we're going to be working with today comes from one of my favorite places that I've ever visited. It's from a place called Mount Hunter, which is deep in the heart of the Alaska Range. It's nestled among some of the country's very tallest peaks. It's actually right next to Denali, the tallest mountain in North America. So it was just a fantastic place to get to spend several weeks in 2013 when a team of myself and several of my colleagues and friends traveled to Mount Hunter to drill about a 700-foot long ice core through the glacier there. So it actually took a lot of work and preparation and logistics to get the ice cores. We had to take multiple plane rides, helicopter rides. We had to ski up and down Denali itself to acclimatize, to train our bodies to cope with the altitude. But it was all spectacular. It was like living way up in the sky for several weeks at a time. It was one of the most memorable experiences I've had as a climate scientist. And it was also all worth it in terms of what we've learned from this ice core. So that's what we're going to focus on today, is this record from Mount Hunter in Alaska. So we know from weather station records in Alaska that The area is warming, and it's actually warming quite rapidly, much faster than most of the rest of the planet as a whole. And we figured that there is probably some sort of change in precipitation and in snowfall that accompanies this warming. So we went to Alaska to collect this ice core to understand how climate has changed in the past. We really wanted to understand the different processes that were going on in this region and how they've changed over time. So primarily, we had two things that we were really curious about. We wanted to know, how has the amount of snowfall changed since we started burning fossil fuels? And then secondly, we also wanted to learn, how has the amount of snow melt changed, again, since we started burning fossil fuels? So join us in the next two episodes as we dig deep into the data retrieved from the snow and ice of Alaska. In Climate Warnings from Alaska Episode 2, we will analyze the amount of snow that has fallen on Mount Hunter by comparing snowfall totals before we started burning fossil fuels to snowfall totals since we transitioned to a fossil fuel economy. And then in Climate Warnings from Alaska Episode 3, we'll compare patterns of snow and ice melt from before fossil fuels became the dominant form of energy to melt patterns in our warming climate more recently. Thanks for being here, and thanks for investing your time to learn more about our warming planet. See you for some data analysis in the next episode.